Can people in the back hear me? Okay. Yeah. Good. Yeah. Just anytime if you cannot hear or cannot see clearly, just shout out. Okay. Yeah. Okay. I think we can get started. My name is Hua Zhou. I'm a faculty in biostatistics and computational medicine here at UCLA. So I will chair the first two modules of this workshop. Before we go into business, maybe just a few words why we are here. So this workshop is part of a series of events, what we call Lange Symposium. And you may wonder who is Lange, where Professor Ken is sitting here. Some people call Ken the biomathematician of the states. I don't know whether Ken likes this title, but I certainly agree. I certainly agree. Basically, these events are to celebrate distinguished career of Professor Ken. To me, Ken is not only a distinguished scientist, but also a great mentor and friend to me, and maybe to many people here. And many individuals sitting here are academic descendants of Ken in some sense. So we all look forward to continue listening to Ken's wisdom in the years to come. Also, we want to thank the sponsors of this event, especially UCLA Department of Computational Medicine, NIH, and NSF, and also ASA Statistical Computing Session. Also, I want to especially thank Professor Jenny Papp and Professor Eric Sobert. So they are the people orchestrating all this and make it happen. Okay. Okay, so I think let's go into the business. So let's get started with this first module. So by the way, I know the screen might be too small for people in the back. So maybe it's much more helpful if you can just open your computer or even your cell phone and point to this website for the workshop, which Jenny sent out a couple of times. Okay, so if you cannot see this screen clearly, definitely you can see on your own laptop or even your cell phone. Also, just a reminder, there are power sockets each row. So if your computer runs out of battery, feel free to use a power socket here in the middle of each row. Okay. Are there questions about this technical stuff, connections and so on? Okay. Yeah.
The restrooms are in that corner of the building.
Right.
The doors on that side, you go walk down the hall.
Yeah. Okay, so I will get started with module 1, just a brief introduction. What are we going to do in module 1 and module 2? Okay, so especially I'm opening this link. So that's the workshop website. It's a link for the introduction of module 1. Okay. Okay, so is this okay? The size. Okay, let me. Okay, so this workshop is called a data science workshop, but everyone has their own definition of data science. To me, data science is more or less what statisticians have been doing for years, which is making sense out of data by using math or statistics. Okay, the only thing that changed is, so in recent years, data is like growing crazy, not only in the volume. Nowadays, like easily we are analyzing gigabytes or petabytes of data, but also it's increasing in variety, velocity, and veracity that some people call 4 V's of big data, or even 5 V. People add the fifth V, which is value. Okay, so that's the thing which changed recently in recent years, like 10 or 20 years, which brings emphasis to the third chunk. The first two chunks is math and statistics, and also the domain problem you are trying to solve. It could be genomics, economics, whatever field generating data. But now a more and more emphasis is shifting to the third area, which is hacking skills. Just because the data is just crazy, it's big and it's complex. So we need spend more time to foster our hacking skills. Okay, that's my view of data science. For young folks here, because in the audience I know there are at least 3 or 4 high school students. Even we have elementary school guy Tyler here. I'm just joking. That's Professor Jing Zhou's son is sitting here. I mean, and I know at this young stage, and when I was a high school student, I have no idea what I'm going to do. But here's a piece of information. If you go to this website, Glassdoor, you click the link. So Glassdoor is a career development website. Every year they are ranking the best jobs, okay? So if you click this link, you go to the website, choose whatever year in the past 5 or 10 years. Always data scientist is among the top 3, or maybe top 5, just to be safe. But anyway, in recent years, data scientist is always one of the best jobs in the States. So think about it. Try to pursue an education path which emphasize math, statistics, and coding, and also domain knowledge. Okay, and then if you are wondering as a data scientist who are going to hire you here, this table may be informative. I'm not going over it. By the way, this is a survey done by ASA, American Statistical Association. So I think this is only for, I think, college students or master students, the salary information and so on. But these are the sectors hiring data scientists and so on and so forth. I'm skipping over. Definitely you can look over if you are interested. And if you wonder for a typical position for data scientists, what kind of skills people are looking for, you can take a look at this typical data scientist post on LinkedIn. And it's too small for me to go over, but you can definitely look over. And then in this workshop, we are going to do something, especially in the module 1. We are going to do something called Jupyter. So what does Jupyter mean? So Jupyter is a combination of 3 programming languages: Julia, Python, and R. Okay. So why do people care? Where from this survey result, essentially this question, table 11, is asking people who got job as data scientists, what are you using? Okay. If you pay attention to the top, these are percentages, the top most frequently used languages. Frequently, people are mentioning, as data scientists are mentioning languages like R, SAS, Python, and the database language SQL. So unfortunately, Julia is such a new language. It's not included in the survey, but in my personal view, Julia is a very promising language to compete with these top ones, Python and R, okay? This table is the same information, what language are most important or most frequently used for by data scientists. It's SAS, SQL database language, or Python, okay? Okay, so that's why we say, okay, for this workshop, let's spend some time just to do with the most popular language used by data scientists, especially the Jupyter, Python, R, and Julia. Okay. Now, language can do lots of things. Okay. Here in module 1 and module 2, we are only going to focus on one or a few steps in the early stage of the data analysis pipeline. Okay, so typically, you are trying to solve some important problem, domain problem, genomics, or whatever. People give you some data files or give you a database. First, you want to import and tidy in the data, transform the data, visualize the data, and then do the modeling and interpret the result, whether it makes sense or not. If not, then we do this cycle, try to transform the data, visualize again, and model again. And in the end, we communicate result to our collaborators and so on. So this is a general a workflow for data analysis. As students, when I was a student, but now also as a teacher, I know in our education program, especially in statistics and biostatistics, we spend most of time on this step. the model, right? Our textbook always start with a nice matrix, a nice vector, and you do modeling, you do linear regression, you do whatever. But in reality, in real world, it turns out people spend a lot of time just to start from a database or data files and do lots of wrangling. In the end, we have our nice matrix and vector, okay? These couple steps are severely lacking in our courses. So that's why we think maybe this workshop will be a little bit more helpful if we trying to take a look at these steps, okay? Because that's actually you spend most of the time when you are actually actual data scientists, okay? So that's the main theme of the first two modules, okay? So in module one, we are going to just demonstrate starting from a couple plain text files, just do all the wrangling, ingest the data, clean up the data, wrangle the data, merge different data, and in the end, we have a nice data frame or data matrix so that we can do modeling, okay? So module one focus on from plain text files to our data frame, okay, for analysis. So module two will be focusing on genetic type data, because when you do genomics, people throw you some weird format like VCF format or plain format, and then as a statistician, I usually you know what I learned is starting from a matrix and a vector and do regression, but you give me some plain files, I don't know what to do with it. Okay, so module two is the pipeline from a genetic format to the matrix and the vector, so we can do statistics. Okay, so that's the main theme of module, the two modules. All right, and especially in module one. So the text file, the data sets is a derived data set from a database called Mimic, okay? And this Mimic is EHR data, so electronic health record data, all right? So it's kind of real data collected by a medical center in Boston area, all right? But what we are practicing now in module one, it's really a very, very small subset derived data set from this database, okay? So that's our material for module one. And especially I want you to have a little task in mind, because you know it's EHR data. What can you do with this electronic health record data? So here I want you to bear in mind a little task. There is something called 30-day mortality rate, which means a patient is admitted into the hospital, and then we look whether the patient dies within 30 days of the admission, okay? It turns out it's extremely important indicator for ranking hospital. You know, nowadays we care a lot about university ranking. It's also for hospitals. There is hospital ranking, maybe also by US News, I don't know. And this is a very important indicator, okay? And then say you are the something called chief data scientist at this medical center, and your boss asks you, say, hey, can you do something? You say you are a data scientist, can you make use of this data so that we can improve our 30-day mortality rate, okay? So just bear this little task. I mean, it's kind of made up, but just to you know, to have a little goal when we do the data wrangling, okay? So essentially, we want to start from plain text files and then end up with a little data frame so that we can do analysis. We can develop, you know, a predictive model, you know, based on the patient characteristics, the gender, the ethnicity, and the age at the admission, and also the vital measurement like heart rate or whatever, or lab measurement at the admission. So we look at that data. Can we predict in 30 days whether the patient dies or not? Okay, so it's a classification problem, die or not. So you can do logistic regression or deep learning. But in this module, we are trying to talk about how can we get such a data frame so that we can do the analysis. Okay, okay. So this is the module one, the little task to bear in mind in module one. One thing I want to remind is the purpose of this workshop is not for us to like memorize all the commands, because it's 3 languages. Each language has their own quirkiness, as their own function names. The purpose is not to memorize those functions. I think the purpose is after the workshop, we know a few key data wrangling concepts, for example, ingestion, joining tables. There's different kind of joining, left, right joining, and filtering the tables, and some data wrangling. Just have a have a big picture of a few key data wrangling concepts. Also gains the confidence. Whatever language you use, any of these three, they are all very mature to doing this kind of task. Okay, I just, the purpose of this tutorial just to show you how easy to do this kind of wrangling steps. Okay, so that's a goal we want to achieve after the first module. Okay, so that's a brief introduction of the first two modules. Next, I want to just do a little orientation how to get started. All right, the first thing is the tutorial we are going through. It's always available through the link. So always you can just look at the slides when we go over the tutorials. Okay. What's better is you might be able to, I say might because this server, we did set up a server, okay, which I hope you can run the tutorials if you want. Okay, so here are little steps how to use this server. First, let me try whether I can do it. So let me open a new tab. Just that's where the server is. Okay, let me make it bigger. Okay, so the first time you go to this link, it asks you to log in. So what are the username? So the username is whatever email you use to register for this workshop. Okay, is the username for that email. So anything before the @ sign in your email address, that's your username. Okay.
All lowercase.
All lowercase. Thank you, Eric. Yeah. Okay. So is everyone okay? Just your email username, all lowercase. Okay. And what's the password? So the password is LANGE because it's part of Lange Symposium. So sorry, Ken. I mean, yeah, but it's Ken's last name. Okay, all lowercase, right? Okay. So first time you log in, you might see some. I don't know. Let me see. Okay. So the first time you log in, because the server needs to set up something for you, okay, it's going to take, I don't know, it depends, 15 seconds or even half a minute, all right? By the way, feel free to raise your hand if any questions, okay?
There are a few of us who can come around and start it.
If anyone's having trouble getting connected.
Yeah.
There's a few seats up at the front. You don't have a desk to work on back there.
Right. There are a few seats in front. If you want to take a seat, great. Yeah.
Sure. You think we'll need it, or?
I'm not sure.
Oh, really?
Yeah, we might get. Let's just put it here.
Sure.
Yeah. Okay.
Only one that works.
So
Everyone who has been able to get in, raise their hand. That's pretty good. If you haven't, you're also welcome to raise your hand. And we could give you, try to help.
okay. So feel free, if you have technical issue, feel free to ask the assistants to help you. There are plenty of our friends here to help. But I will continue since it looks like half of you are able to log in. So the first time you log in, you will see something like this. So this interface is something called Jupyter Lab, okay, which is very popular in the data science community, all right? And on the left, so there are a couple tabs, all right? So this tab is a file browser. I think by default, you will see this browser, this tab. And here you can see there are two folders there. So lost and found, I don't know what it is. But the important folder is this folder called Lange Symposium Workshop, all right? So essentially this folder contains all the tutorials you can run, okay? Okay, so, and you can navigate through the folders. So you can see, ignore the Docker folder, which is not useful for the during the workshop. But you can see the tutorial for module 1 introduction. Essentially, that's the web page I went through. Okay, so you don't need to run anything there. So the first tutorial is the R tutorial. So it's in this directory. If you double click it, you can see a couple of files. All right, look for the file name ending with IPYNB. That means IPython notebook. So that's the file we can run. All right. Is this clear? So I'm pointing to the first tutorial. That's module 1, 02 R IPython notebook. All right. If you double click it, you should see the tutorial. All right. Okay. And then if it's the first time you see Jupyter Notebook, essentially it's divided into chunks. Okay, so that's the first chunk, that's the second chunk. So you can see the first chunk is just text. There's no code. You can tell from here, it's something called a markdown. That just means it's a text. All right. So you can run this chunk of text. Of course, it's doing nothing because it's not code. All right. So how do you run this chunk? So there is this play button here. So that's how we run this chunk, because now this chunk is highlighted. So you just run it. It's doing nothing because it is text. It's not code. Okay. So if we move to the second chunk, you can see now it shows the code. So that's code. If you want to know what kind of code it is, it's R. It's shown here. Okay. So essentially, what this notebook does is under the hood, there's the R session. Okay. Essentially, this notebook is running that R session. Okay. So this is R code. You can run it. So you run it, it shows the output from this function called session info. All right. And then you can just keep running the chunks one by one. Okay. And during the tutorial, as a presenter, we are essentially run this notebook, but not on the server, but on locally on this laptop. But if you want to try the tutorial, you can just run this way. Okay. Are there any questions about running Jupyter Notebook? Yes.
Will we be able to access it after the workshop?
Yes, yes. Essentially, this whole folder is a GitHub repository, and that's we will share that with you. So actually, you can even access that repository now, but it's there. All the material is there.
You want to say something about the Mimic?
The Mimic data set?
I mean, the fact that it's not actually public. Right?
Oh, that's right. So your question is, can you access material? All the code, all the Jupyter Notebook tutorials are there except the data set, because the Mimic data set is open for free use to researchers, but you have to go through a training procedure. So so if you want to run this data set afterwards, after this workshop, you need to go through that process. To have access to that data set. Yeah. Thank you, Eric.
Small registration and then tutorial step, and then they allow you to access their data.
Right, right. Okay. So that's how we run the tutorial, the Jupyter Notebook. So sometimes you see I don't click this, but still I can run it because there's a keyboard shortcut. So I often do that. So essentially you highlight the cell, and then on the keyboard, you press the Shift key and then the Enter key. Then it's running this chunk. Okay. So often I just don't click this button. I'm just doing this on keyboard because it's easier. All right. Okay. Okay, so is that all I have for now? So also, because the server, we set up this server, but it's a shared resource. All of us are using that same server. Sometimes it might crash, your kernel might crash, and so on. So one tip is related to this second tab. Okay, So the first tab is file browser. Second tab is you can see the kernels you open, in later this afternoon, after you run through, run like an R tutorial, Python tutorial, you might see many kernels here, okay? Remember, each kernel under the hood, it's some language, it's Python or R running there, which is, taking up some resource, all right? So if you are running tutorial and the kernel dies, usually that means you exhausted the allocated resource for you, okay? One tip is you can clear the kernel you are not using anymore, okay? Just to release some resource so you can run other tutorial, okay? So you can clear by click this this button or just shut down all the kernels, okay? So that's a little tip, okay? Also, when you are running the tutorials, the third tab is also very useful. So it's a table of content. So essentially it helps us to navigate because some tutorials are long. So from left, you can navigate quickly to the appropriate session, for example, to here. Then you can just switch, jump between different sections quickly, okay? So these are the little orientation for the Jupyter lab, okay? Okay, so are there anything I haven't covered? So there are some tips. Yeah, there are lots of people here can help. Maybe for people from Operability group, you can raise your hand so you can identify the one closest to you. So just grab any of them.
Where the name tag will be able to help you.
Yeah. All right. So we are all able to help you. Okay. Yeah, don't keep running many kernels at the same time. I mentioned that. Yeah, I think that's all I have. Okay. So so any questions? Okay, so I'm going to close my server session. I'm just going to stop my own server. You don't do it. It's just I just want to save some server resource and then I log out. So without further ado, let's move to the first tutorial, which is R. Okay. And I'm glad to introduce Dr. Xiaoqian Liu. So Xiaoqian actually just got her doctorate degree like 2 weeks ago. Yeah, congratulations. From North Carolina State, I worked there for 5 years before I moved to UCLA. So that's Department of Statistics. Okay, so Xiaoqian is going to go over the R tutorial. Okay, so let me just close this. Maybe so okay here. As well.
The screen looks good. Okay. Thank you. Hi everyone, I'm Xiaoqi. I'm very glad to be here today to give you a short tutorial on R for data science. Dr. Zhou just introduced how R is important for data science, particularly for statistics and biostatistics. So in this tutorial, we'll use the Mimic dataset to clearly see how we use R for data analysis, including data ingestion, tidying and wrangling, and also data visualization. Unfortunately, we cannot cover everything, but I hope this short tutorial is interesting and helpful to you. I think everyone now can see the screen, and if you log into the server, you already on this page. And if your kernel is not R, you can change the kernel on the top right corner here. And after the tutorial, if you just use your laptop, if you cannot find the R kernel in your Jupyter Lab, then you can find this following link to install it. So we already showed the system information. So here the R is the version is 4.2.1. For different R versions, it might affect a little bit on the outputs, but I think most likely we can get the same outputs. So before going into details on how to use R for data analysis, I like to introduce a typical workflow for a data science project. Dr. Jill just kind of briefly introduced the kind of this workflow, but I'd like to kind of go into details. Of course, when you have a real data set, the first step is to import the data into your R. It typically means that you take the data stored in a data file or a database, then you load it into data frame in R. But when you analyze real data, most likely we cannot use it directly for our data analysis. Sometimes the data might include some information that is not related to our analysis, or the data format might not be suitable for the analysis. So in this case, you need tidy or clean the data. So in brief, if the data is tidy, each column is a variable and each row is an observation. After we have the tidy data, a common step is to transform it. Transformation includes like narrowing on observations of some particular interest. We'll see this later, and also creating new variables that are functions of existing variables. We'll also see this later. And together, tidying and transforming are called data wrangling. Then once we have the tidy data and with the variables we need for the analysis, then we can move forward to analyze the data. So visualization is a kind of a powerful tool for us to better understand the data. You can, after you visualize the data, you may find something unusual, or you can raise some new questions on the data. And modeling is kind of a complementary tool to visualization. Whenever you have a kind of a specific question or precise question, for example, in our task, we want to build a predictive model for the certain mortality, then we need to fit a model. So this part is kind of the core part of data analysis, and it requires our knowledge of data analysis and statistics. So from this part, then you can get some findings or conclusions. Then we will communicate these results to others, let's say our clients or the audience. This is kind of the whole picture or the whole workflow for a data science project. Then the question is how we do this in R, how we realize or how we implement this whole workflow in R. The answer is Tidyverse. Tidyverse is a collection of R packages from data ingestion, wrangling, and visualization. You can find the kind of the website by clicking this link, and you can see that for each step we just seen in this workflow, we have corresponding packages to implement or to realize the goals in each step. For example, for importing the data, we have readr. For tidying, we have table, and for transforming or visualization, I think once you know something about R, you possibly know ggplot too. It's very powerful and very useful in practice for data visualization. And also we have other packages for the other steps. The lead developer of Tidyverse won the 2019 COPS President's Award. It's the Nobel Prize of Statistics. So you can know how important or how useful this ecosystem is. So to install the Tidyverse ecosystem, you need to run install.packages, but on the server, it's already available, so you don't need to install it again. But you do need to load the Tidyverse ecosystem by calling library Tidyverse. Here is the kind of the information of this ecosystem. Now we know we have the tools in R for our analysis. Let's first see the mimic data files. So here, this trunk is basically save the path of the mimic data files in this mimic file, mimic path. We'll use this later. And here I would like to show you the picture of the directory structure of this mimic data. Make it a little bit smaller. You see the kind of the structure is kind of complicated. It includes 35 files, but no worries. In this tutorial, we only focus on these 4 files: ICU stays, admissions, patients, and chart events. We'll first peek into the content of each file so that we can know what kind of information we can gather from each data file. But before that, I'd like to briefly introduce the PAP operator. The PAP is used to linearize nested function calls. If you see the code here, you can simply think that, I want to put it into, okay, into the same line. Okay, now, you can simply think that the PAP operator in R is given in this format operator. Then it simply it puts the output of its left-hand side as the input of its right-hand side. Or you can think that it will nest the left-hand side into the right-hand side. And we can also write the different functions into different lines and connect the functions by this operator. And so nothing new, but it just makes the nested code much more cleaner. And if you want to see details, you can read this paragraph carefully and compare the code using PAP and the commonly used nested code. But I think it's much clearer, and you can read this after the tutorial. So I'll not go into this coding kind of details. Yeah, now let's go into each data file to see what kind of information we can get from each file. Let's make it bigger. Okay. So the first data file is ICU stays. In this data file, each row is an ICU stay. One patient can have multiple ICU stays during one hospital admission. You can see that here, subject ID indicate the particular patient. Then you have some other information, let's say first care unit or in time, all time, and some other information for this particular patient. And ICU stay, you have the stay ID. And for the admissions, each row is a hospital admission. One patient can be admitted multiple times. Again, you can see the subject ID here, and also we can find admit time. Let's see, admission type. Some information related to admissions will be included in this data file. And for patients, each row is a unique patient. So you can see that for each row, we have a unique subject ID, and we have gender, age, and some other basic information about the patients. For the chart events, each row is a specific vital reading during an ICU stay. So you can see for each subject ID and each stay ID, you have the item ID. Item ID here is the kind of a key factor or key variable in this data file. You can find the dictionary for the item ID in the D items data file. So we can see if the data, for example, here, if the item ID is 220045, it's a heart rate, and you can find others. Let's see, blood pressure. Anyway, each ID has a specific meaning for that vital reading. And in this tutorial, we'll only focus on the following two vitals, heart rate and temperature. So we'll save this 2 item ID into this select chart item ID vector. Now we have kind of know what kind of information is included in each file. Then the first step is to ingest the data or import the data into the R. So we'll ingest the data as tables in R. Tables from tidyverse are enhanced data frames from R. So how to read the data or how to ingest the data, we'll use readcsv here. It's in the readr package. And readcsv is a function that can handle the gz files well. It parses the column data types based on the first bunch of rows. Most of the time it works well, but if not, you can use the column types argument to explicitly specify column types. I know if you read this kind of synthesis, you feel like kind of confusing, but whenever you have a question about a function, or you don't know how to use this function, or how to assign the values to the arguments of the function, or what kind of function arguments are available in the function, you can simply use the question mark plus the function name. For example, maybe we can try it here. Okay, yeah. Oh, I think that's because I didn't run the, let me see. Okay, now you can see the detailed description of this data file of this R function. You have the description, you have the usage, including here is the readcsv, include all the arguments, and you can find the meaning for each argument and kind of what kind of type you can, the value you can assign it to. And also, let's see, you can, here the value indicates the output from this function, and you can also find examples so that you can try or compare it with your, in your case. So this is pretty helpful. Just to remember, use this question mark to solve your problem if you have any question on a R function or not. That is this. Okay, now we know how to, we know we can use readcsv to ingest or to import the data. So let's first let's try this for different data files one by one. The first one is ICU states. So okay, so here, I don't know why. Okay, so here we oh, I see. I need to kind of rerun all the things. I'm sorry. Don't do like me, please. If you are running the code, please do all the things from the beginning. Then this way. Okay, now it works. So I think I don't no need to do this again. Okay, now here we read the ICU states data into the ICU states table, and you can see the summary here, and it shows the first 10 rows of the table, and you can see each you can see the number of each row, and for each column it has a variable name and even the data type. So you can see it's much clearer than just call this system call, and that's why we see that it's an enhanced data frames in R. And then you will store or ingest the admittance data into the admittance tables. Similar structure, but you can find the NA in red here. That means they are missing values. Similarly, we ingest the patient's data into patient's table. And again, we have some missing values. And for the chart events, it's the original data file is pretty large. It's more than 2 gigabytes. And reading in this data actually turns out to be challenging. Even if we only read like 4 columns into R, it takes more than 10 minutes. So please do not try run this on the server. The main constraint is the memory size. Read CSV is designed to read the whole data set into memory, and it might miss some problem if the data size is too big. And a solution to this data volume issue is database, and we'll briefly mention this later. Since in this tutorial we'll only include these 2 item IDs, so we created a smaller chart event data file called chart events filtered item ID. So you can run this on the server, but it still takes some time. So but it's much faster. Yeah. Okay.
Here, I want to emphasize the data set you see for gzip. So often I see people get gzip file first and they do the decompress. But remember, in big data, you decompress the gzip data, you get a much larger data file, which taking up a lot of resources. And here from this code, you can see it. Almost all these languages, really R or Python, and directly G the gzip file. All other that file. So you don't need to expand it. So here is one useful thing to do.
Okay. Thank you, Dr. Yeah. So here we have the chart events, a smaller chart events data file for our tutorial. Let's play with this data file or play with this table. And here we give the point plot for this particular state ID on the heart rate. You can see. Yeah, you can see these are the heart rate at different time for this particular state ID. And here, once you want to give a plot in R, please try ggplot2. Here you see the kind of the point plot, and you can also try to add the color. You can see if you add a color, yeah, you see different colors for different values. It's kind of a reflection for the value. And you can also try the shape. So FC ggplot2 is very powerful, and I use it very often. And you can try other things, even change the legend, the color, the shapes. Remember that we want to develop a predictive model which computes the chance of dying within 30 days of ICU stay based on this 4 baseline features: first care unit, age, gender, ethnicity, and also the 2 vitals, heart rate and temperature. But the case is we want to restrict to the first ICU stay of each unit patient. But how to do this? How to restrict it to just the first ICU stay? So next we need wrangling and merging the data, the tables we have already in R. Our strategy is, first step, we identify and keep the first ICU stay of each patient. Second, we'll identify and keep the first vital measurements during the first ICU stay of each patient. And at last, we'll join 4 tables into a single table for our analysis in the following. So here we'll use some important data wrangling concepts, let's say group by, arrange, slice, and we'll see this later. So let's first see the the first step, restrict to the first ICU stay of each patient. Some related concepts, I have included the links here. You can find the detailed distribution, but for the first case, I'll explicitly explain how this code works. Remember that the pipe operator would kind of nest its left part into the right part. This means we'll work on this ICU states data file, or the ICU states table. We'll group by the rows in this table, and by what? By the subject ID. That means for the rows have the same subject ID, we'll treat them into as a single or a same group. So then we'll apply the arrange function on the objects on the outputs we obtained above. So we'll arrange the rows or the grouped table by the in time. And here by group equals true means that we'll arrange the rows within each group. The in time indicate the ICU stay in time. That means for each group, the first row would be the first ICU, the first ICU stay or first in time. Then the second row would be the second time. And then slice height n equals 2 means that we'll select or slice the rows n equals n equals 1 here. Equals 1 means we only take the first row. That corresponds to the first in time or the first ICU stay. So now you see how we get or how we restrict to the first ICU stay of each patient. So after that, you can see for each row, you will have a unique subject ID, indicate a unique patient. And for the in time, that's the corresponding first ICU stay in time.
Don't forget to run it.
Okay, thank you. Oh, this one also takes some time.
Yes.
Yeah.
And also, I want to mention that a range word in tidy words, it's just means sorting. It's just sorting.
Yes, yeah.
I don't know why they don't call it sorting. They call it range.
Maybe you should speak the comment, so more people can hear it.
Oh, okay. Yeah. The arrange basically means sorting. So it will sort the rows by the in time. Yeah.
What does the output function do here?
Oh, this group function, since we have the group by, this group function just kind of ungroups the rows we just did. But I don't think it's a kind of a key factor here. Yeah. So so if you have the group by, you possibly have the same. No, I think no. I think the ungroup here is just kind of redo or undo the group. Yeah, the group by. Yeah. And for step 2, we'll restrict it to the first vital measurements during the ICU stay. So we already know the first step. So this one kind of will do something similar, but you also have some other related concepts. Let's say select, mutate joins, and pivot value. But you can find the details in these links. I'll not go into details here.
Maybe you can pause here for a second.
Yeah.
I want to point out the importance of types. Just think about this data flow without types. You're going to write this as like a 12 times nested function, which is very nasty code. But with the types, it's very easy to read. So that's why all the language that have some concept of types. It's just for writing elegant and readable code.
Yes, the pipe operator makes the code much cleaner to read, and also if you want to add some function, let's say before the the third one and the fourth one, you can basically insert another row, another function call. So it makes the code much cleaner and easier to modify. Yeah. So now we have the, remember here that we put the kind of the filtered ICU state data file into this ICU state table first state. And also we have the chart events data file called chart events table first state. So then, okay. Then we'll merge the 4 tables, filtered ICU states and also chart events. And remember, we have the admissions and data tables, patient tables. We'll merge all these 4 tables into a single table that will be used in the following data analysis. So here we'll use mutate. You can find the detailed information in this link, but here you find that we create a new variable age in time that is a function of some existing variable I ever mentioned at the beginning of this tutorial. And this is kind of the final table we'll use for the following data analysis, data visualization. Yeah. Did I run this one? Okay, now let's do some data visualization. It's always a good idea to visualize data as much as possible before any statistical analysis. So remember, we want to predict this certainty mortality by this set of predictors or variables we call it. Let's start with a numerical summary of variables of interest. So we select this four variables from this mimic ICU cohort table. And here is a summary of these different variables. You can see for first care unit, you have the count for each care unit. And for gender, you have the count for female and male. And also for age, you have the mean, max, median, and for the temperature. For different categorical variables, you have the counts, and for the continuous variables, you have the kind of different quantiles. And I would like to want to ask if you spot anything unusual in the from this summary. For example, here the temperature, it has a minimum value of 0. It's actually not meaningful in practice. So here I would like to highlight that whenever you analyze a real data set, please consider the practical meaning. If the value of some variable is not meaningful in practice, then there must be something wrong, or maybe you need to kind of further figure out the problem with the data. So then we'll continue to the universal summary. We give the bar plot of the first care unit. So you can see we have the counts under different care unit. Yes. And here I would like to suggest you set your own theme to make your plots look good to you and your readers or audience. So when you include a plot into your paper or into your slides when doing a presentation, it's very important to give a good plot that is readable and good to the users or the readers. And you can change the font size of the title of the 2 axes, and later you can see the legends. And also we can give the histogram and box plot. So I forgot to remember that whenever you, if you want to give the bar plot, you have this geom bar function. And if you give the histogram plot, you have this geom histogram function. And also we have the corresponding box plot function. So ggplot to us that it's very powerful or useful for the data visualization, since it has almost all the available functions for you to do the data visualization. Maybe you can do some exercises on your own, try to summarize discrete variables or continuous variables. And maybe try to figure out if there's anything unusual in your variables. Here, I think we do not have time to go through these exercises. Let's move to the binary summaries. This part will show the tally of 30-day mortality under different first care unit. Yeah, you can see that ggplot also have the legends here. You can also change the title and the text of the legend. And here it includes the counts for the false and true of the certainty mortality under each care unit. And it just to keep this code, and if you add a position equals to fail, then you get the kind of the percentage of the true and false for each for the certainty mortality under each first care unit. You can also try the tally of 30-day mortality under for different genders. And again, if you add a position, you get the percentage, and definitely the summation would be 1. And then you can try other similar exercises for the certainty mortality under different levels of other predictors. We do not have time to cover other things. For example, for the data quality control and the imputation, if your column or the variable has too many missing values, or you may consider to exclude it from your analysis. Similarly, if the samples or the rows have too many missing values, you should also consider exclude them from your analysis. But when the missing value or when the missing rate is not too high, then you can try some imputation imputation methods to impute the missing values. And for modeling, we didn't cover it, but you can find the models in tidy. Yeah, here the tidy models. It includes a lot of kind of functions and available techniques for you to fit or build a model. You can also try to evaluate a model using resampling and also tune model parameters. Remember that we met a trouble with ingesting the big data file, the chart events data file. A possible solution is database. So you can try the Google Bigquery. We cannot cover this in this tutorial, but what is Google Bigquery? You can find it on YouTube and also find some other tutorials online. I think for learning a programming language, you can try attending some, let's say, workshops or try some useful books, but the internet or always try to find some useful materials online. It's quite convenient and accessible. In summary, there are some pros and cons of R. So it's an open source language. There's no need for a license or a fee. You can even create your own R package and put it on R CRAN. And it's a platform independent language. You can run it easily on Windows or Linux or Mac. and it provides support for data wrangling and visualization, particularly for visualization is very useful and powerful. And I think all the kind of data scientists, if we want to do some visualization, they will try R first. And also it's a language of statistics. So it provides almost all the implementations of statistical analysis. I think in statistics, if you have a new method, if you want your method used by others, the first step would be try to implement in R or build our package and put it on CRAN. Again, it has some cons. So for the data handling, R would store the data in physical memory, so we'll have some problem when the data is too large. And also the the speed is relatively slow. So at least for me, I do some optimization stuff, but I think R is not friendly to optimization or to solving an optimization problem. But in general, I would recommend R for data analysis, or if you're a guy in doing some data science work, it's pretty useful and commonly used by the statistic and data scientists. Yeah, that's all I have for today. So let me know if you have any questions on this tutorial. Thank you.
I think we have some time at the end of module 1 just for questions and also for technical issues, so we can delegate questions and so on to that time. So again, I want to mention there are so many commands here. The point is not to memorize command, but it's just to have a high level understanding. This kind of data manipulation is very easy using R. So next module is Python, and using the same data set, Dr. Seiyong Ko is going to show how you can do this kind of similar data manipulation using Python. Just a brief introduction. Dr. Seiyong Ko got his PhD in statistics from Seoul National University, and currently he's a postdoc fellow working in our group. I have to say, Seiyong is a computing guru. So whenever I have questions on computing, like those highly technical ones, like GPU computing and so on, parallel computing, distributed computing, I always go to Seiyong, including setting up this server. So you know, it's very useful to know him. You know, if you have a computing question, Seiyong maybe it's Seiyong and other folks like Alfonso are very helpful. Okay. Okay, so Seiyong, please open up your tutorial. It's Python. Also, I want to mention Seiyong has been teaching Python for machine learning here in the collaborative workshops.
Thank you, Paul. So, hello, my name is Seiyong Ko, and I will talk about Python for data science. So let's talk about why we use Python here. Python started as a general purpose programming language, which garnered larger user base from diverse disciplines, unlike R, which specializes in statistical computing and data analytics. So it is more domain specific. So it has a rich pool of scientific libraries with strong community support, and it has many useful libraries beyond scientific computing. So it is natural to directly utilize scientific computing results in diverse applications, such as image processing, natural language processing, gaming, and others. And disciplines like machine learning, which is not that far away from data science, Python became the de facto standard language in many companies, so you may be required to use it sometimes. And for deep learning, packages like TensorFlow and PyTorch, they are all in Python. So many people are using these things, and you might be required to use Python to use these packages. In Python, the set of packages used for scientific computing is called SciPy ecosystem, or for scientific Python. Libraries are important characteristics of how Python works, and each application has its libraries. And for scientific computing, these are the packages you are going to use a lot. NumPy for numerical arrays, SciPy for more numerical routines such as numerical integration, interpolation, optimization, and linear algebra statistics. And this application, Jupyter Notebook you are looking at, is based on Python. And for plotting, we have Matplotlib. And for data analytics and R-like data frames is Pandas. So we will use this Pandas package throughout this section. And for machine learning, the most basic package would be scikit-learn. These are all included in Anaconda distribution of Python. So if you download it, it comes with all the useful scientific programming packages. So let's check the system information with this cell. And before we move on, I'm in charge of the cluster setting today, and we have limited resources for each user on the cloud. So we need to make sure that don't forget to shut down the kernels you are not using. So let's shut down the R kernel right now. We only have 3.6 gigabytes of RAM for each user, so we need to do that right now. I was nervously monitoring what is going on with the cluster with this many users earlier this session, and I'm pretty glad that we are running 52 sessions running on that cluster right now. Now let's get to Pandas. Pandas is a Python library for working with datasets. It supports data frame structure like in R. It is actually modeled from R's data frame. How to load the library? Here's the syntax. Import pandas as PD. Many people will so this imports the pandas library and rename it to PD, two-letter acronym. And many people will do that. So it is like an idiom in Python now. And it is similar to NumPy. We often import NumPy as to two-letter acronym and P. And then we set the path for the mimic data. And then let's see how to load the dataset. For ICU stays, the CSV.gz file, we use read CSV function under PD pandas package. And we need to predetermine the columns with date time values with the keyword argument parse dates over here. Let's read in this data set.
So the parse dates is having Panda to parse these two columns as dates.
Yes.
That's okay.
And for documentation of functions, you can type, you can press Shift tab to see the documentation here. And similar to R, you could do question mark and then function name in the code cell. Let's run this cell, and it shows pandas.core.frame.data frame. So the variable read in is in an instance of So the very red in is an instance of data frame. So let's talk a little bit about what this means. It is about object-oriented programming. Python has built-in object-oriented programming support. You don't need to write everything in object-oriented programming in Python, but many packages use it, so you will need the very basics of it. The OOP paradigm is based on objects, which is bundled with data representing the properties of the object, and code in the form of method. So here are the four concepts. Class is what defines the data format and available procedures for an object. So in this case, data frame is a class. An object is an instance of a class. So this variable ICU states underscore df is an object. And attributes is properties like column names, number of rows, number of columns, and others for data frame. And how to access it, the syntax would be data frame name dot attribute name. And method is actions, which is in the form of functions applied to or performed on the object. And syntax for this would be data frame name dot method name, and inside the parentheses you provide the arguments. Now let's read in other data frames. For admissions, we have this, and these are the columns in dates. And we have patients data set. And for chart events, we have reduced version of the file. And we will read in only 4 of the columns, named stay ID, item ID, chart time, and value num. And we will parse them as the data types of double precision and petaflow 64 for stay ID, same for item ID, and string for chart time, and again double precision floating point number for value num. And chart time is in date format. It takes about 7.5 seconds to read in this data set. And for filtering, the method we use is called query in Pandas. And inside a string, we give what to do. We are only taking the records with stay ID this and item ID this. And for plotting, we use the package matplotlib. And it is also another idiom in Python to import this pipeline subpackage of matplotlib as plt. And this is called magic command of Jupyter Notebook. It will show the plots in line. And then let's plot this. Let's draw the scatter plot like this. And with this command, you might be wondering where's the pipe operator we use for R? The answer is that we don't need it in Python for this case, because we have method chaining for linearizing method calls. The dot operator is evaluated from left to right, so we can chain another method call or attribute access right after obtaining the results of the previous method call or attribute access. So this is a Python way of avoiding nested calls. So by using another dot, we we can get to another attribute, and by using another type, we can get to this method. One limitation is that we can only do this for methods or attributes of a class. So, for example, we cannot do this to print function because it is not a method of data frame. And for general operations, we have pipe method in Pandas for doing things similar to that. And actually, if you insist on using pipe operator in Python, you can do so. But for data analytics, I think majority of people will not do that. Now let's get to data wrangling. We are doing the same tests as R. So 30-day mortality rate we are getting. The items we have is Foursquare unit, age at in time, gender, and ethnicity. And force measurements of the following values since ICU stay in time. We are taking our heart rate and the temperature. And we restrict to the first ICU stays of each unique patient. We are using the same strategy as in R. So first step is to restrict to the first ICU stay of each patient. So ICU stays data frame has 76,500 rows, and it will be reduced to 53,150 unique ICU stays. What we are doing will be sorting the values first by the subject ID and then in time, and we will group it by subject ID and take the first record for each group. Then we have 53,000 rows. Step 2 is to restrict the first vital measurements during the ICU stay. So we are merging this ICU stays data frame with chart events with the chart events data. And the function is named merge, unlike in R. It was called join. And to indicate that we are doing right join, we put right in the keyword argument how, and we are doing so on the column named stay ID. And then we will filter based on chart time, and then sort based on stay ID, item ID, and chart time, and group by stay ID and item ID, and then take the first one. And then we will drop chart time, in time, and out time columns because we don't need it anymore. And we will parse item ID as string to rename it easily. And then we pivot the data set and rename these column names into more readable name, heart rate and temperature. Then now we have the data set in hand. And now we will merge 4 data frames as we did in R. And we will mutate some of the columns using the function named assign. The syntax is using anonymous function or lambda function. So the syntax might seem to be a little bit more complex, but if you have some programming background, it is more straightforward sometimes with this format. This is anonymous function definition. So if argument of function is this df here, and this is the one line output of that function. So the question was, what does pivot do? So let's try just running up to this point right before the pivot. Oh. And let's see what we have. So before doing pivot, we have stay ID, item ID, and value num, the three columns we originally had. And item ID indicates heart rate for this number and temperature for this number. And we are changing and we are changing this format into this format. So we are making these two numbers columns of the data frame like this. This was for 220045, and this was for 223761. And row names are now stay ID. We had multiple of them before, and we are merging it to a single row with these two columns. That is what we are doing with pivot.
Other language is called reshape. So you have a long data frame, you want to reshape into a Y, or you have a Y data frame, you want to reshape into Y. So in Julia, except that in R and the Python are pivot, but it's essentially reshaping the data frame.
Now let's merge the 4 data frames and transform some of the columns. And then now let's get to visualization. We want to model 30-day mortality rate with the covariates for forced care unit, age at in time, gender, ethnicity, heart rate, and temperature. Let's start with numerical summary. For numerical column, we can obtain mean, standard deviation, and quartiles using the method named describe. And for categorical column, we obtain the number of unique values and value with the most appearance and its frequency. So forced care unit, gender, and ethnicity, these are categorical columns. So we see total count, unique values, most appearing value and its frequency. And for numerical columns, age at in time, heart rate, and temperature, we have mean, standard deviation, minimum, and the 4 quartiles. And we see again the strange values, minimum 0 for temperature and heart rate. And if we want to obtain counts of each value for categorical column, we have the method named value counts. And you can see the detail of each column. Now let's get to univariate summaries. Before we start, let's import the Seaborn package for styling the figures a little bit to make it look a little bit like ggplot2. This package is originally for statistical data visualization. So we import this and let's just set. And then the syntax is a little bit more no, not here. So So let's see the bar plot of Foursquare unit. We have to get value counts first and then get to the plot attributes to get the bar method. And here is the bar plot of the Foursquare unit. So the syntax may seem a little bit more verbose than what was in R. And here's the histogram for age at in time, and box plot for age at in time is here. And then let's get to bivariate summaries. For exercises, it is same as what we had in R. Again, this is a little bit more verbose than what we had in R. First, we group by Foursquare unit, and then take the column 30-day mortality rate, and then get value counts, and then unstack it. And then reverse the column order to make true come first. So this is the stacked bar plot for 30-day mortality rate versus Foursquare unit. And then for bar plots of relative values, we provide this normalized keyword argument for value counts. It returns the values to sum up to 1.0. And then versus gender, we do the similar. So that is what we do this task in Python. So pros and cons of Python would be that, well, its advantage is that it is general purpose, so you can directly use the data analysis results into different disciplines, and it has wider user base, so it has rich package ecosystem, and it is readable, and it's not sometimes faster than R, because more computer programmers are working on Python than R. Disadvantage would be that it has less statistical analysis packages, and libraries may be harder to understand, and visualization is more convoluted than R. This is Python, and yeah, thank you.
And maybe we can defer questions to the end of the module. Okay, first let's see how we are doing with time. So I think we are a little bit behind the schedule. So I will try to be brief in my tutorial. We are 2/3 done. Okay, Jupyter we have done PY and R, but here's the Julia. Okay, okay, let me turn on the table of contents. Maybe let me just move. Sorry, I'm I'm jumping back and forth, but let me just jump to the last one, the pros and the cons of Julia, because Julia is a new language, and lots of people ask me questions about Julia. Why? Because Julia is my favorite language. So basically, it's a warning. If I say anything, you should keep that in mind. Julia is my favorite language, so I'm biased. But anyway, okay, sorry. Okay, first let me talk about con, and then I will talk about pros, and then I will go to the beginning of the lecture just to highlight what I'm saying here. One biggest con, I mean, disadvantage is people saying, oh, Julia is such a new language. I think 1.0 version of Julia is 2018. It's like 3 or 4 years ago, right? People always say, it's such a new language. You know, I want to do this, do that. I just don't believe it's in Julia. I want to say, I mean, maybe 5 years ago it's the case, but for now, everything is there. Okay, I mean, as I will go back to the tutorial, I will show. I mean, everything you see in Python and R, at least for this example, like all those data manipulation, it's all there. So I kind of don't agree. I mean, Julia ecosystem is not rich enough. I think it's there, but the biggest advantage is the second one. It's a smaller user base because it's a new language, right? Not every of my colleagues are using Julia. Basically, a direct consequence of smaller user base is when you Google, say, how to do like a pivoting a data frame in Julia. If you search this, how to do this in R, most likely the first 2 hits give you the direct answer. It just works because the language is stabilized for so many years. But in Julia, you know, you Google search some instruction. Sometimes it's I mean, you get some of the top hits is like 2 years ago, but Julia is a new language. 2 years ago, the version is even pre 1.0, which is so different from the Julia 1 point something. So that's the issue. I think that's the issue. All the ecosystem is there. It's just the user support. The community is not there yet. So that's the biggest, to me, it's one of the biggest disadvantage of Julia. Another thing I complain a lot about Julia is, you know, in R, we have R Studio. We are not doing R Studio, but for the statisticians here, you know, every statistician loves R Studio, which is such a powerful IDE, which means you write code, you debugging, you do visualization, you do everything in that IDE. Python, I believe there's something similar, but it's for Julia, it's not the case. The powerful IDE is not there. I mean, currently the best tool is something called VS Code. It's Visual Studio Code. That's the best you can get, but still it's far from. I mean, it's just not there yet. It's not like R Studio. Okay, so that's my another biggest complaint about Julia. Also, there is one issue I will demonstrate in this tutorial is the issue is something called the time to first plot. It relates to how Julia works internally, because Julia is something using a technology called just-in-time compiling, which means the first time you call the function, Julia is trying to compile that code into a low-level code, into machine code. That's also why Julia is fast, because it's compiled. But for some very complicated package, like a plotting package, and also for there's a package called loop vectorization, some package depends on this package. All this, you know, all packages which has loop vectorization as dependency has a long pre-compiling time. So, which means for plotting, you do the first plot, you wait for long, but after that first plot, other plots are super fast. But it's an issue, right? The first call is slow, so that's also the biggest issue. So these are some cons compared to Python and R you saw. Like in Python and R, but I think you already saw when you do plotting, the plot just come up immediately. But in Julia, the first time you do that plotting, it takes forever. Okay, you will see in a second. So these are the cons, and it's a pros. I mean, there are some disadvantage why it's still my favorite language. It really because what I'm doing, because I'm doing lots of scientific computing, which means numerical optimization. You know, or for some folks doing differential equation and auto differentiation, this kind of scientific computing, it's just amazing, Julia, because it solves some problem called a two-language problem. So that's why those folks at MIT, they decided to design a new language because they want to solve this issue, which is called two-language problem. So what's this problem? This problem basically it says, you know, as a high-level language like R and Python, we all love it because, you know, you don't need to compile it. You just write code, it just runs immediately. So everything's nice. But until you want to write some production code, which means when you want to scale that up, then they suffer. Python code and R code suffer. And then what's the solution? So as a R programmer or Python programmer, you have to go to a low-level language. You need to write code in C or Fortran, or C++ or Java, and then wrap those low-level code using the high-level code. So it's a notorious two-language problem in scientific computing community, okay? which is kind of painful because before I started using Julia, I used R or MATLAB, and there's a low-level language because I was working with Ken. I need to code Fortran. It's kind of painful, right? You need to write low-level language and then wrap things up. It's some efforts, okay? And Julia is exactly for solving this issue. As you will see in a second, the Julia code, just like Python code or R code, very readable. You can run directly, but also when you run it, because it's just in time compiled, it's fast, okay? So I don't need to jump back and forth between a high-level language and low-level language anymore. So that's the biggest advantage of Julia. Okay. Another advantage of Julia is something called interoperability, which means within Julia, it's very, very convenient to call whatever other language you can think of, MATLAB, Python, R, share, Linux share, or compiled library. So within Julia, it's extremely easy to call whatever other language. So this is also a great advantage of Julia. So that's why this is just my pitch of Julia, because I represent Julia in this workshop. So, okay,
Sorry.
yeah.
The new the compatibility with current modern hardware.
Oh, yeah, because Julia is it's a new language. It a couple years old. Just at the design stage, they're already incorporating this new hardware, including GPUs and so on. In Julia, I know in other language, in R, my student attempt to use GPU within R, it's very, very painful. Essentially, it's a two-language problem. You have to switch to C, CUDA-C, to write GPU code. But Julia, you can just write plain Julia code, and it's going to get compiled into GPU and CPU at the same time. So that's very elegant. So in terms of this kind of high performance computing, here is also a link to a news piece which declares Julia joins something called a petaflop club, which means in scientific computing, it's one of the languages which can achieve this throughput in a high performance computing cluster. All other languages are almost all of other language can achieve petaflop is a low-level language. Okay, yeah. So biggest advantage is computing and the two-language problem, avoiding two-language problem. So that's why I like Julia. But here, for the time's sake, I don't know whether I want to run all this. Maybe I'm not going to run it. I'm just going to show you a result. Again, the point is not to memorize the commands. I just want to show, everything is here, ecosystem, in terms of data manipulation. And maybe it's even faster, but maybe I'm not running, but I'm just showing. To pass the data file, remember the data file is gzipped, right? No problem. In R and Python, same for Julia, just call it. I mean, since it's a plain text file, delimited text file, so in Julia, it's a CSV package for passing a plain delimited text file. Okay, just call this, and then this is the famous pipe. We see how pipe is so helpful in R and in Python. This is the pipe in Julia. Okay, you can do pipe. So this is creating a stream of the data file you are trying to passing. Okay. And this is something called a sink. You can pipe this stream into whatever sink. It not only for data frame, if you have other sink, for example, database and so on. So lots of other data formats, you can pipe the stream into whatever you want. Okay. So here we pipe into data frame. So the end result is a data frame. Okay. And we can see here, the only thing I set is it's kind of similar to that argument in Python. So how does Julia know some variables we should pass as date time? Okay, so here is this one. So because if I don't put this, it's passed as string. Okay, but here I tell Julia the format is this format: year, month, day, space, and then hour, minute, seconds. Okay, then whenever Julia sees this string, it's going to pass into date time. Okay. I think that's the only trick I need to do to make this, to make ingestion of this file successful. All right. So you get this, Also, it's the same story, admission table. So I have a data frame for the admission, and then a data frame for patients, okay, and a data frame for chart events, okay. So remember here, we reduce the data size because the original data size is too big. The gzip file is 2 point something gigabytes, after parsing, it might be times 10 or something. So it's occupies all the memory. So we prepared this smaller file. But if you go to the other two language, I think it still takes some time to parse this smaller file. But here you can see the Julia runtime is 1.8. It's very amazing. I mean, compared to even for data parsing, I think it's faster for R and Python. Okay, so at this point, we passed 4 data frames, all right? And then we want to do some data manipulation. So you already saw some key concepts in R and Python, given a data table, we do some filtering of rows, select some rows, satisfying certain criteria. So in Julia, it's called filter, all right? So we start from this data table, and then we select certain rows satisfying this criteria, state ID equal to this number, item ID equal to this number. Then we get the less rows, and the select is for selecting the column. I don't need all the columns. I just need some columns. So I just select these 2, and then further pipe into data frame. Okay, so this is my smaller data set, and then I can do plotting. All right. So the plotting is a totally different syntax, but again, it's quite straightforward to do. All right. So this is just plotting for this specific state. What are all measurements of heart rate? Okay. So everything is here. You saw in R and Python, and then the same story. Next, we want to do some data wrangling using group by, sorting, and slice. Really, you just need to figure out what's the function name. So all these big concepts, group by, sorting. So in R, it's called arrange. In Julia, it's called sort. And unique is just given a group table. Oh, sorry, here I think I'm just picking up. It's kind of picking up a unique row for each subject ID because it's sorted. Essentially, I'm picking up the first ICU state for each subject. Okay. So that's the step 1, and then step 2. It's a big pipe. Okay, so here we are just for each subject, I just want to keep the first ICU state, and for the first ICU state, I just want to keep the first vital measurement for the heart rate and body temperature. So that's the purpose of this whole pipe. But again, you can see all the element is there. So I want to join to a table. There are left join, right join, inner join. We are skipping the details, but it's all here, okay, in any of this language. So we do right join, we filter rows, and we sort, and slice, select columns. So unstack is related to one earlier question. So pivoting, it's really a reshaping. So you have a very long table, you want to reshape it into a wider table by putting one column as extra variables. So in Julia, it's called a stack and unstack. I think pivot wider, it's long table into wide table. In R, it's called a pivot wider. In Python, it's called a pivot, and then you specify which pivot in argument. In Julia, a pivot wider is stack. Unstack. So pivot longer is stack. Okay, so it's all here. And then it's a long pipe. By the way, this one means, remember, pipe is taking the output from previous comment and the pipe into input of the next function. Okay, so this is indicating where do you want to put that, previous output as an input argument, which input argument. So this is indicating where to put the previous output into the current function. All right, this long pipe, again, the runtime. The first run might be longer. You can see this is the first run, but 58% of time is spent on compiling. But if I run again, it doesn't need to compile again. It's going to be much faster. All right. So this I mean, if you want to try, you can try 3 different sessions to compare this, like the timing for this long chain. Okay. Okay. So and then merging data table. So here I'm using a couple of left join, and then insert columns is adding extra variable, because sometimes you want to transform a column into taking log or whatever. In R, it's called a mutate. So in R, mutate means adding extra variable. In Python, I don't know what's this called, but Seyon should know. But in Julia, mutate it means insert columns. I think it's more straightforward. It's just adding extra variables into your table. And then I get this final table. Okay, so this final table, I create a new variable called 30-day mortality. This is an indicator variable, indicating whether this patient dies or not. 0 means this patient does not die within 30 days of hospital admission. So 1 means this patient died within 30 days of hospital admission. So this is in statistics, we call something, we call this a response variable. We want to model how can we predict a person dies or not within 30 days. Okay. Also, here is a little thing. So here we can see this column, it's a Boolean. So it's true or false, but there's a question mark. So question mark means this column has missing data. Okay, so that's what this means. Okay. All right. And then data visualization, again, the command is so different, but everything is there. You just need to read the documentation. Okay. Maybe it's a little harder than other language to find this documentation because the user base is smaller, but it's there. Okay. And maybe Ming Su later we'll talk a lot about visualization. Also influenced by Ming Su, I'm trying to use the one plotting package called Makey. Okay, so this is all by Makey, these plots. All right, bivariate summaries and so on and so forth. Okay. Okay, so just as a summary, sorry it's too quick, but tutorial you have access to it forever. After this workshop, you can try yourself. Okay. Let me expand it a little bit about the first counts disadvantage. People are complaining it might have smaller ecosystem. I don't agree, because ecosystem is there. It's just hard to find documentation. It's on the contrary. I want to argue. I mean, it's also my complaint. I mean, some ecosystems are too rich. For beginner, it's very hard to choose. For example, plotting. You know, in R. Everyone says use ggplot2. There's no question, just use ggplot2. In Python, use matplotlib. In Julia, you will find like at least 5 plotting ecosystem. For beginner, it's very, very confusing which one to use. So that's also my complaint. It's not only about plotting, it's also auto differentiation. You know, people are using that for machine learning a lot. You write a function, the code is going to take derivative for you. So that's auto differentiation. Again, for auto differentiation, there might be 7 or 8 packages there in Julia. It's just too rich, and as a beginner, I have no idea which one to choose. That's one another complaint. Also, deep learning is the same. I mean, there's no single dominant package in Julia. There are lots of parallel development. In some sense, maybe it's good. I mean, the competition is good, but also it can be very confusing. So that's another warning about Julia. I think that's all. Sorry, I'm going too quick, but I think you get the message. And you will hear a lot, Julia, in the second module. So I want to, how are we doing with the time? So I want to stop here. Do we still have time for FAQs and QAs and exercises? Until 3. Oh, we have 6 minutes. Great. Yeah. Hey, Ming Su.
What's the next time?
So the question, what's at time? So this is for getting the timing. So essentially, it's a macro. So essentially, you want to time something. You just put at time before the chunk of code you want to time. So here I'm timing this whole chain. So essentially, Julia is going to run this chain of command and then output the timing information. So it shows to run this chain of commands, it took 8.69 seconds. But the breakdown is also important. It says, 60% is spent on compiling. So which means if I run this chunk again, this time is gone. It doesn't need to be compiled again. So that's for timing. Yeah, at
You
time.
didn't have the at time command, you get exactly the same result, just without that top line.
Yeah.
Of timing.
Yeah, timing essentially is giving this information. Yeah. So the question doesn't have to be regarding the last lecture. Any question, or if you have some technical issues, I think it's a time just to raise hands and we will come to you and try to solve it.
So I feel like a lot of the code is spent sort of manipulating whatever the control data format is.
Right.
And then getting that into like a nice matrix. That's the type of thing that they write about in like textbook, right?
Yeah, basically this table is like
That's the-
a statistics textbook starts with this, right?
Yeah.
So this module 1 is more about people give you a bunch of gzip text file, what kind of manipulation we can bring data into this form. Yeah.
What exactly is what's the initial data format that you were working really hard to?
Oh, a great question. So the data is here. So so that's in the beginning of Xiao Chan's lecture. So these steps is the first step is just to peek into the data format. So here we can see this file, ICU states file. It says it's a CSV file gzipped. So here we just peek into see. It's just to show the first 10 lines. Sorry, the formatting, it's bad. It should, yeah. So essentially, this is one row.
So it is organized as
It's a tabular data for sure. Yeah, it's tabular data. But again, you see, we need lots of steps in order to get that final table so that we can run regression, right? Yeah, it's the point of this module is really about,
In the
How-
next module, we'll talk about how to deal with non-tabular data.
right, genetic data. Yeah. So yeah, it's a bunch of gzipped CSV files. Yeah.
So there's the breakdown, you can still ask a question, but I'll just say this, right now there's a breakdown, there's some refreshments out in the lobby here, but it would be better if you took it out into the, outdoor area for eating and drinking.
Can you recommend some textbook or resources for learning the theory of organization?
For Julia, take my course. I'm joking, but if you are at UCLA, for sure, you don't need to take it. You can sit in my class. I'm teaching statistics. Yeah. For textbook, I don't know of any textbook which is not outdated quickly. Yeah, because Julia is moving fast. So, but if you go to Julia language website, so there is this learning tab. Go to the learning tab. There are lots of great resources here. Tutorials, Julia for data science. It's all good. Yeah. So you Google, let's first Google Julia. Google Julia. And then the first hit is Julia programming language. So click it. And then there is a tab called Learn. And lots of great stuff there. Yeah. Yes.
Sorry, if other people Google Julia, I'm not sure that's the first hit. Maybe your first time, if the thing of your history or something, I don't know.
Oh, really? Oh, okay.
Google Julia.
So Google is personalized. Okay. Yes.
For electronic health records.
Yeah.
Are those going to be a standard format and then those will be files?
Okay. So I think in academic environment, most time people organize as text files, But if you are in actual hospital and also in company, most likely it's a database. You have to query database. So that's why, you know, the one very important skill is SQL, just because that's how you get data. You need to use data query. But also, we don't have time to cover in this workshop all this language, Julia, R, and Python. They have a very, very good database interface package, just to help you. For example, in R, you know, suppose you are very familiar with tidyverse, you almost don't need to change the code. You just need to switch dplyr package to dbplyr. The same code will work on database. Yeah, same for Python and Julia.